Good morning. Today we have learned to the simplex method. That is a simplex, a linear programming algorithm that can solve problem have more than two decision variable. Last lecture we have seen that we have solved the graphical method with the linear programming problem two decision variable, and the simplex method a linear programming algorithm that can solve program having more than two decision variable. The simplex technique involves generating a series of a solution in tabular form called tabulus. By inspecting the button row of each tableau, one can immediately tell if it represents the optimal solution. Each tableau corresponds to a corner point of the feasible solution space. The first tableau corresponds to the origin. Subsequent tableaus are developed by shifting to an adjacent corner point in the direction that yields the highest or smallest rate of the profit or cost. This process continues as long as positive or negative rate of profit cost exists. And we have seen the algorithm of the simplex method, that is first iteration set to the start iteration including finding the initial basic feasible solution, and then we find the first initial basic feasible solution, and then we apply the optimality test. It is the current basic feasible solution is optimal or not. If yes, then stop. If no, then the next iteration platform and iteration to find better basic optimal solution. And we have seen the simplex method in the tabular form. Initialization, a transport of all constraint to equality by introducing slack, surplus or artificial variable as follow. That is constraint type, that is less than variable to add, that is constraint type. This is less than type, then it is called slack variable, and greater than type is surplus variable that is greater than is slack, and less than is surplus, that is add artificial variable, and equal to plus artificial variable. Then simplex method in tabular form construct the initial simplex tableau, that is basic variable is s to a, and this is the coefficient of the objective function in, that is x1 up to xn, and is the slack or surplus variable, that is s1 sn, and this artificial variable a1 an, and RHS is b1 up to bm, and z is the objective function of coefficient at the different signs and z value. That is simplex method in tabular form, that is the test of optimality. That is first case is maximization problem. The current basic solution is optimal if every coefficient in the objective function row is non-negative. And case second, minimization problem. The current basic feasible solution is optimal if every coefficient in the objective function row is non-positive, that is negative. And simplex method in tabular form, that is iteration third, that is step first, determine the entering the basic variable by selecting the variable that is automatic a non-basic variable with the most negative value in case of maximization, or with the most positive in case of minimization. In the last row, put a box around the column below the this variable and called is pivot column. And simplex method in tabular form, Determine the leaving the basic variable by applying the minimum ratio test as follow. Pick out the coefficient in the pivot column that is strictly positive, that is greater than equal to 0, and divide each of this coefficient into the right hand side, enter for the same row. And third is identify the row that the smallest of this ratio. And fourth is the basic variable for the row is the leaving variable, so replace the variable by entering the variable in the basic variable column of the next simplex tableau. Put a box around this row and it is the pivot row. Step third, simplex method in the tabular form. Solve the new basic feasible solution by using elementary row. The operation multiply or divide a row by a non-zero constant. Add or subtract a multiple of one row to another row, and to construct a new simplex tableau, and then return to the optimality test. And the specific elementary row operations are: first, divide the pivot row by the pivot number and the number in the intersection of pivot row and pivot column. And second, for each of the row that has a negative coefficient in the pivot column, add to this row the product of the absolute value of this coefficient and the new pivot row. And third, for each of the row that has a positive coefficient in the pivot column, and subtract from this row the product of this absolute value of the coefficient and the new pivot row.